In this video, I will explain another approach called regularization method or shrinkage method that basically introduce some cost function so that your training process does not convert to the minimum point of RSS value but converts to some other point so that your overfitting issue can be resolved. And even in some cases with this regularization method, the outcome naturally find a subset of your input predictors that has very nice the output prediction. So here I will explain two very famous Ricci regression and LASSO. These two methods are very similar. The first one, the Ricci regression, basically minimize this cost function yi minus beta 0 minus beta 1 xi 1 minus beta p xi p square RSS, which is function of your parameter beta, plus lambda times j1 to p beta z square. Okay, so basically Ricci regression find the argument of your parameter beta 0 to beta p that minimize the RSS function with respect to your parameter beta plus lambda times the two-norm square of your parameter vector beta, which consists of parameter beta 1 to beta p. Okay, so here the two-norm means, so basically for any vector x, you can define some p-norm. So here p is any real number, but usually we consider p is greater than or equal to 1, which is equal to summation of the absolute value of xi p to the p to the 1 over p. So the beta vector two-norm square is essentially the sum of squares of elements of vector beta. Okay, so this is Ricci regression, and LASSO is pretty much the same. LASSO solve argument beta 0 to beta 1 beta p that minimize RSS function plus lambda times j1 to beta absolute value of beta c, which is essentially lambda times beta 1 norm. So Ricci regression called two-norm regularization, and LASSO regression or LASSO is called one-norm regularization in some places. Okay, and why these two norms or one-norm regularizations or cost function is very useful for finding very nice parameter set beta. So there are many explanations for this Ricci and LASSO regression, and in this video clip I will give you two different approach we can understand the Ricci and LASSO. The first one is Bayesian approach. So in machine learning, the difference between MAP, the maximum of posteriori posteriori. Yes, and MLE, maximum likelihood estimator. The difference between MAP and MLE are very important. This is very important concept for many different machine learning fields. Basically, the beta MLE find out the argmin or argmax, the probability of your data for given parameter beta. But the MAP is the process finding out the parameter beta that maximize this conditional distribution. Probability for parameter beta for given observation D. Okay. And again, from the base rule, this part is equal to probability data for given parameter times probability your parameter over probability your data. Essentially, because the MAP is the process finding the parameter that maximize this conditional distribution, and this is the process of argmax, the maximum value is not important. We just need to extract the parameter beta that maximize this conditional distribution. So if the denominator will be the same for every parameter beta, we can simply ignore the denominator. And this is the case. The property D does not depend on parameter, so we can simply ignore this. So the MAP process is argmax beta that maximize probability data for given beta times probability beta. So the difference between MLE and MAP is the existence of probability beta. So this is called prior distribution. This is called prior distribution, and we have the same conditional distribution. Your distribution or your probability of your data for given parameter beta. So MLE does not weight anything to your parameter, but MAP consider something. If the parameter looks like very general, then you weight more. If your parameter looks like very weird, then you weight very tiny thing. So MAP people believe that there exists some prior knowledge on your parameter, and we have to utilize the prior knowledge. Okay, so basically we can categorize machine learning researchers into two different categories. One is frequentist and one is Bayesianist. And frequentist just believe the data, does not believe any prior knowledge. But Bayesian scientists, they usually believe there exists something prior. We have to use the prior to get more accurate prediction. Okay, so this is the MAP and MLE. And Ricci and LASSO regression follow MAP rule with two different prior distribution. Ricci regression basically follow the Gaussian assumption. If this is Gaussian or normal distribution, then this is Ricci regression. If the probability distribution follows double exponential, or Laplace. The name of double exponential is Laplace distribution. Then this is Ricci regression, LASSO regression, LASSO. Okay, so the shape of Gaussian distribution looks like this, and the shape of Ricci regression looks like this. Okay, so this is 0. This is 0. So double exponential distribution weighs more on at 0, which means LASSO usually have many 0 compared to Ricci regression. LASSO regression, the main assumption of LASSO regression is our parameters will follow double exponential distribution, which means our parameters generally have many 0 values. So when you optimize the LASSO cost function, RSS plus lambda times L1 regularization term, naturally your solution will contain many 0 values. So after LASSO learning, you will have many 0, which means this learning process naturally select input predictors that predict output very well. On the other hand, the Ricci regression, the L2 regularization, which is very smooth, so which just penalize the weight far from the 0 value. So the Ricci regression just regularize if your some parameters are too high and some parameters too low, then penalize the too high parameters so that the value becomes more close to 0. Okay, so that is Ricci regression. Another understanding of Ricci regression and LASSO regularization is Lagrangian dual form. Essentially, when you have this optimization problem, yi minus beta 0 minus beta 1, xi1 minus theta minus beta p, x ip square I want to n minimize with respect to the variable beta 0, beta 1 to beta p. This is the simple learning process without any regularization, without any selection rule. We will find some parameter that will minimize your training error. But we want to make our parameter becomes more regular, not too high value, having some more 0 value, so that our model, our trained model, less overfitted. Okay, so for this purpose, we can include some constraint for this optimization problem. The constraint means our parameter, sum of our parameter square is less than or equal to some constant s value. Okay, so this is convex optimization problem. This is convex function with respect to parameter beta 0 to beta p, and this is convex set. What is convex function and what is convex set? Please find the definition from Google. This is very simple. And when your optimization problem has convex objective function and convex constraint set, this is easy to solve. And one possible approach to find out the solution for your convex optimization problem is Lagrange dual approach. So Lagrangian dual approach change this problem like this. If you have convex constraint, you multiply Lagrange multiplier called lambda, and then make this problem, this dual problem, this max lambda for positive lambda, minimize with respect to beta. So you first minimize plus lambda Okay, so the rule is move this term to here so that this value is some condition less than equal to 0. With this condition, you multiply Lagrange multiplier lambda and then move this constraint to the objective function. This is the form. And then solve the same minimization problem, but you control the Lagrange multiplier so that this solution is maximized. After solving this dual problem, you naturally have the solution for the original problem. This is the Lagrangian dual approach. Okay. And when you look at this dual problem, very interesting. This is again RSS value, and this is lambda times L2 norm square minus S. But minus S is just constant. Okay, so which does not act for finding beta 0 to beta p. So essentially, we're solving RSS plus lambda times L2 norm square cost function minimization problem all the time. So essentially, the Ricci regression means we have this constraint when you have beta 1 and beta 2 parameters. We have this constraint, so we only consider parameter inside this circle area. And among beta 1, beta 2 inside this area, you want to minimize RSS. Ricci regression is the same. We find the minimum solution for your parameter beta 0 to beta p and RSS value, which is function of beta. And for this original problem, you introduce some constraint. What is the constraint? J1 to P, the absolute value, beta J less than or equal to S. Then the Lagrangian dual problem makes this form, max lambda equal to greater than equal to 0, minimize RSS beta plus lambda times summation J1 to P beta J absolute value minus S. Again, this is constant with respect to beta. So for this process, we don't need to consider this term. So essentially, this is equivalent to the LASSO. Okay. And which means we consider this area when you have beta 1 and beta 2. And we find out the solution of RSS among point inside this kind of rectangle area. Okay. And the rectangle and circle area is very important. So usually you minimize your RSS value, and the minimum point usually located at the corner. So you have some zero values because this corner always at the axis, which means you have at least one zero value. All right.